So my name is Anders. I work for Issue, and I'm a front-end developer of sorts. And we built this, which is a thing where you can upload PDF files, and then you can watch them in this nice, like kind of magazine-like reader. It's built in Flash, and it has been for 10 years. And Flash is end of life. So over the last year, we've been exploring how to build this with modern web technologies, and we've ended up with this. Now it looks a little odd because of the screen size thing, but it full screens like that. Then it sort of looks this now. Again, because the screen size, it doesn't perform so awesome as I would like it to, but you can kind of grab it and do stuff with it like that. And it's responsive and works on all the devices we have to test on, except for mysterious reasons, some Windows devices with Chrome. And if you happen to have a Windows device with Chrome where you see the problem where the reader doesn't really show up, then we would possibly like to buy your computer because we can't reproduce it anywhere. But anywhere, the reader is done with React and Redux, which is sort of linking together the UI, which is a little bit around, like a little bit down here and some up here. You can sort of see some information about the magazine. And you can zoom and zoom a lot, and then it will re-render the page in sort of high resolution. And this is done mostly server-side. We have a big conversion farm with a lot of machines that receive the PDF, and then it's converted, split up into images and text. And we have a JSON format that basically encodes all the fonts on a page, and where the letters are, and which images are on the page, and how they're supposed to be rendered. And then we use canvases in the app to render each letter where it's supposed to be based on your zoom level and all that. We render like one letter at a time, and it's surprisingly enough, that's fast enough on all the devices we sort of have to test on. It can be on old mobile devices be a little bit laggy, but if you have an old mobile device, you kind of expect the internet to be laggy anyway, so that works out. We of course want to improve it, but that's just the way it sort of is. What was during development the biggest sort of issue we had was really the choice of React and Redux, which was awesome for building all the UI level. There's not so much UI being seen like in this view, but it also works in embeds and pages where there's a lot more UI and there are some complicated rules. And it was really nice for building the user interface and handling all the states of it. It's nice to have Redux and React. It's really not nice when you want to build fluid animations like this, where you draw a lot. We draw basically the entire screen. And we want to know there's some rules you have to follow when we want to do fluid animation with JavaScript. And it's really difficult to follow those rules when you're doing React. So I tried to do a presentation mostly about how we solved that problem. And let's see if it's interesting. So I'm going to take a step back. How do you do fluid animations in a browser? You use CSS transitions. And it's like that. Always. Unless you're into some really strange things, that's what you do. That's how you should animate anything in a browser. And you use CSS transitions. You only do transforms on the translate and opacity things. So no removing or adding elements during an animation. Instead of doing display none, which also causes layout trapping, you set opacity to 0 and do pointer events none, because then it sort of disappears. And these things animate nicely. But unfortunately, sometimes you also have like touch events going, or you're animating based on like a timer or something else that cannot really be controlled easily with CSS. So then you need to follow some other rules. And this is exceptional thing. Already here we're into something that for 99% of pages you should not be doing this. You should be doing something that you can do with CSS. And this works nicely with React, right? Doing it with CSS, because you can just toggle a class and then the animation will take care of itself. And React is sort of built for that and fast enough for that. But sometimes maybe you're doing an image gallery or an endless scrolling list or something where you need to reuse DOM elements, and that's not doable with CSS, or or as I said, you're handling touch events, and that is sort of possible with CSS because you can style something as being like draggable. How do you want this to look? I want it to look draggable, which is odd, but you can. And sometimes you want to do a panable and scalable pixel perfect representation of made-for-print content with crisp font rendering and a WebGL page flip, and you also need to do stuff like that there. So, and a cat. So the best practices for doing fluid animations with JavaScript is to do all DOM updates and style updates and or like drawing and canvases, everything that sort of adds something visual. You need to do that inside the callback from the request animation frame. And outside of request animation frame, you do as little as possible. So in mouse or touch event handlers, you do nothing basically. Just remember where was this? Just store the x and y value of the event. You can calculate like velocity if you're doing like something like you want to do what's it called? The scroll inertia scrolling is something you can calculate velocities, do an average of where mouse events was. But simple math and just storing events. That works. No rendering. You want tight control over what happens when and where always. So here is a nice example of that, which is done with JavaScript. It's a really shitty example. It just creates some elements. Then it has a little bit of state with an X and Y positioning. And then it registers some event handlers. And basically it does that right on mouse down. It says like, hey, now I'm dragging. And it stores where did the touch start. That's the touch origin, and which position was I at when I started. And on each like mouse move event, it sort of calculates how much have I moved, like from my origin point, and then it moves the thing. And then it just adds these event listeners, and then it has this update loop where whenever there's an event, it says request update, and request update just check, have I already requested an update? And if I haven't, then I call request animation frame for the update function. And this is how you basically want to do it. Inside this update function, you can then add the styling changes, move stuff around, whichever the way you want. And it looks, stupid flash. It looks a little bit like this, and it's not very fun, right? It's not. I made all the slides and the things today, and this was the best I could come up with. I didn't have a designer. What it does have is a little bit of interface. Up here, there's an element that's updated with the state where things are. So this counts as UI. So let's try and do a time-lapse trace of this. It's very small from where I'm standing. So. So I think most of you probably know this, but if I look at this, right, you can see each frame. Here are mouse events, and they're small. Nothing happens basically. There's just the event, and it doesn't do anything. And over here, there's a draw. Also, very little happens, but more stuff happens there. And followed by that, there's the browser does work. That's the purple and green stuff. And that's nice. This is how we want our apps. Let's go back to the presentation. So we decided to use React and Redux to build the reader. And we can start with another example, which is doing this in like the natural way, like best practices Redux. How would you want to do this stuff? So there's some actions like for the same, like start move, end move, and just move. This is my event handlers in the plain vanilla JS app. Then I have a reducer that handles these things, and it does the same, right? It sets, like, remembers the origin where the touch started and where the box was when the touch started, and then it toggles is dragging, and on each move it calculates the state and stores that in the state of the X and Y properties. And I connect that stuff to my components. First I have some components. I have a container that dispatches these actions on move, and I have an item that is like the item, the yellow box, And I have my little interface thing that updates, shows the state. And then I have a wrapper that collects everything together. And I connect the main thing, I connect that to my state, so that whenever there's a mouse event of any kind, like I dispatch these actions. And that looks, if I can find my thing here. So it sort of looks the same, but if I trace it with the timeline, now these are a lot deeper, and so it's a little unfortunate. Now it says 15 milliseconds here for a frame. And when I was testing it, the reason I sort of stopped adding stuff here was because at the time, apparently my laptop was frame dropping already there. So I said, oh, great, this simple thing I've done here already has problems performing, but now it doesn't frame drop, so which is more natural. But what it does is it draws all the time. Every time there's a mouse move event or any mouse event, it's followed by these blue things, which is the browser doing rendering. There's also this pretty deep stack of stuff that JavaScript executes, which was not there in the vanilla app. And this doesn't look so bad here, but that's because it's a very simple app. This actually doesn't scale very well. Because it's drawing outside the request animation frame, it's updating the DOM on the mouse move events, and it's doing this dispatch thing which runs through the Redux loop, which is expensive. And it's basically breaking all the rules that there were for doing fluid animations with JavaScript. And so why do I say dispatch is expensive? It's not really in this app, but it kind of is, because when you do a dispatch in a Redux app, like from any like React component can do a dispatch, and then there's usually an action creator of some sorts running, and that is getting dispatched, and it's going through this chain of middleware and these reducer functions, and actually then it goes through the middleware chain, both like on its way down to the reducers and then up again, and then it hits this connect method where it's connected to the state of the React tree, and sometimes if you're using reselect or something, you maybe have some selector code running in there, memo and also they're fast, and all of this is basically fast, but it's a lot of code. In the reader app that we were doing, this turned out to be most of the code. It was a pretty large app, right? Most of the stuff we have was either like reducers or action creators or selectors. So we had most of our business logic was in selectors. And then when this is done, then there's all the components. And if you like just connect to the top, then the top component gets new props, and that's rendered. And these prop updates propagate down the React tree, and that also takes some time, right? Each React component has to figure out, hey, should I do something on these new properties I'm receiving? And in the end, it reaches like the render methods of all the components that decide they want to do something, and they return some stuff that then goes to this virtual DOM that React has. It's reconciliation, where it decides which changes actually do have to go to the DOM, and then they get applied. And some of the other like modern frameworks like Inferno or Vue or something, some of the other ones are doing these updates inside request animation frame, but React is not. React uses a different strategy where it sort of batches them. It waits until, okay, now there's some changes to be done to the DOM, and then it just does them. And this is not necessarily what you want, because if you want to do a fluid animation, then React might decide that, hey, now I want to update, and this is in the middle of some frame, and the update takes maybe 5 seconds, and then you pass the request animation frame, so the actual drawing to the screen comes to the next frame, and then you drop the frame, and you get uneven. It's not so bad to drop a frame if you do it consistently, then you just have a lower frame rate. But if you occasionally drop a frame, like sometimes you hit 60 frames per second, sometimes it's 30, and it's up and down, then it looks really jarring, your animation isn't fluid. And this is what you do not want. You want to have control of what happens when it happens all the time. And this was a big problem for us with the reader. This was actually our #1 performance problem. So we went to to Twitter, actually. Like the guy from Dan Abramov, who designed Redux, he has a saying like, you don't need a single source of truth for everything. Just make sure you have a single source of truth for every particular thing. And then we decided that, well, we kind of didn't want that really. This was what was causing the problems, right? We were trying to have all of our state in this Redux tree. So why didn't we just use internal state in some of the components, like the reader really, like which page it's on and all where the touch events go when I'm doing the animation. Not that was a flash reader. Let's just close that. When I'm doing this animation, like where I am on the page, this doesn't really concern anyone else. But then there's a problem of the interface here, which is why in the test app I have this little up in the corner, the little interface thing up here, because this is a difficult part, right? How do we synchronize with the rest of the app? They want to know some parts of the state, like which page is on, and if we want to keep this state inside a certain React component, and we also want to give other components access to it, then that's a conflict. So we decided to have a synchronization point. And I don't know, this example is probably boring, but let's do it anyway. No, that's actually the one that shows the. We changed the action stuff, so now there's only a position changed action, and then the component that owns, like in this case, owns the box, but in our case owns the reader code. That one has all the touch events by itself, and when it changes, it just updates local state. Like this state is tracking stuff, and when you do mouse down, it uses set state instead of dispatch, and this makes this avoids the Redux dispatch loop and all the middleware, and it also avoids the connect method, and it avoids updating the entire React tree because only this component is concerned. Then what we did is, like I did in the vanilla JavaScript app here, at the end of each of these mouse event handlers, we call a request update function, and this request update function, it checks state whether there's a pending update, and if there isn't, it requests an animation frame, and inside that animation frame, we do a dispatch, which is in this case called this on position changed method. That one is connected, the Redux app, and does a dispatch. So now at least we can control when the dispatch happens. So when there is a request animation frame, we know that dispatch is in that, and the entire loop that we shown before, this one, it at least happens inside an animation frame. So we are kind of certain that all of this happens, but this part, like the diffing of the virtual DOM and actually updating the DOM, we're still not really sure of that, because React, as I said, does its batched updates, and we can't really be sure of when it wants to do an update. But let's see what it looks like. So this looks exactly the same, but trace it with the timeline. And now, these ones are mouse events, the small one. They're a lot smaller now. Before, everything else looked like this. And the mouse events now are pretty small. They're still, like in the vanilla JS app, they were nothing. But now they're much smaller. They're just doing set state on the internal component, and we're avoiding a lot of stuff. And they're no longer followed by browser update things, because that's not doing any rendering here. We're just updating state inside this component. And over here, when the request animation frame fires, lots of stuff happens. This is a dispatch loop, and following that, there is some DOM updates. So in this case, React decided to do its update immediately. Sometimes there's batch updates, and they cause frame drops, and they cause rendering at odd times during the frame. I don't know if I can see one here. Probably not, because this is a small app. But this was still not giving, at least me, much happiness. There's stuff happening here, and I wanted, like in the Vanilla.js app, I want to have this control. I want to decide when we draw, and especially as we were going into WebGL land, where we are rendering like the entire frame, like everything in the reader is drawn each frame. We can't reuse anything from the last frame. We're redrawing all the time. And that's unfortunately a little bit of a power drain, but that's a separate issue that we are working on handling. But at this point in our development history, we were this is how we're doing it. And yeah, the problem here is, like as I said before, there's sort of a warning. Now we're duplicating state, right? The position is now both inside the component that receives the touch event that has its internal state, and it's also inside the Redux tree. And that's because the little number in the corner needs to be updated also. Share that number. And that one can then be updated because of these dispatches in the request animation frame. And this is fine, right? It's a synchronization point. At least we decided it was fine. Everything inside the reader that knows about the absolute position at this time, it must only look there. There can only be one source of truth for any particular kind of code, any component we decided. And the components that were UI components that were outside of this reader core, they could then only look in the Redux tree. And this is how we decided it. It's sort of like a cache pattern, right? We decided to use the Redux tree as a cache for this. So avoiding this, this part of all this code from React, avoiding that was more difficult, because React doesn't really want you to. It wants to own the DOM. It wants to do its DOM update, but you can kind of convince it to have unmanaged DOM objects in it. And you do that if you, in a React component, say, in should component update, just return false. Say this component should never update, never ever. Then React will always assume that the tree underneath that is always like correct. And you can then in component did mount just create some DOM elements that it doesn't know anything about. And you can clean, if you clean them up again in component will unmount, then React doesn't mind that you have your own DOM nodes inside. You can then not really receive any props from other parts of the tree, like like normally that happens if you say this component should update, then you get this component will update and component did update and the render method called. But we're not interested in calling render anyway, because we don't want React to do any updating. So we just want to know if there is new props available, so we can do our own rendering at our own pace. And it turns out that before should component update, there's a lifecycle event called component will receive props that also gets the props, and you're not supposed to do anything with them at that point, but you can. So so that's a nice thing to do. There is another example. If I can just get showing that. The store is, and the actions are completely unchanged from before. This container that before would receive the touch events, it doesn't anymore. It just creates this one element in its render method, and then it always returns false into the component update. And in component did mount, it then creates an instance of this mover class, I'm calling it here, which is it initializes with whatever state is in the Redux tree at this point, and then it appends it to its own element, and then it calls update on this mover component. And the mover component then does basically what the Vanilla.js app I did in the beginning did. It creates some DOM elements and attaches some DOM events, and then on mouse move, it does this request update, which again, if there's a pending update and if there isn't, it requests an animation frame, and inside the update, it manually moves the position of the box. So, if we look at that.
But are you using React for anything there?
Here, in this one, I'm using it to update the number up here, because I still do the dispatch to the Redux tree after each drawing. And then I can build my UI, which in this case is pretty simple. It's just a, it's just a number, but it's still there in the code, right? It's this display component that is like inside this connected main thing, and it gets the properties from where the X and Y is. And these X and Y are dispatched after each draw by this mover, like by calling the onPosition changed, which the mover gets in its constructor from this bridge function up here. A
little bit.
Yeah, well, in this app it's a little bit, right? Because it's basically not an app; it's just well, something. But in the real reader, it's basically all this stuff, like whether or not this should be shown or not. It's if I have this and I do a page flip, which I can do if I use the keyboard, I think. Yes, then it fades out, and it does that because this one receives the touch event and it starts turning the page, and as it starts turning the page, it updates the position, which it dispatches, and then it's called by the Redux app, and the Redux reducer knows that, hey, if the position is changing, then none of the UI elements should be showing, and it fades them out. And there's a million business rules like this that are very easy to implement in React, but would be very tedious if you had to manually go in and find each DOM element and hide it and show it. And there's also the slider down here that shows where you are in the document, and there's current pages, and there are stuff that's been handled by the React and Redux part of it. If you look at this small thing in whoop. So if I use the timeline here now to record and do like that. So now I finally have what I was looking for. I have mouse event things are very small. They're basically nothing. I just update some state, remember where the mouse pointer was, where the touch was. And on the draw, I thing. But that's okay because this is inside a request animation frame. I can do basically update my whole app. And as long as React is working with us as doing its update inside this request animation frame, then we get what we want, that the frame is fast, and at the end of it, the browser does its work. So this is where the reader is. You can use this bridge I made. You can do that anything, right? It's just DOM elements inside. You can do anything. So what we're doing is we're doing WebGL. You could also just draw on a canvas. We also did that for a long time during the development. We were just drawing in a 2D canvas. You can do endless scrolling lists where you reuse DOM elements where you're in complete control of it. You can update them when you want. So this is, at least in my opinion, if you need this two-way synchronization where you both want the power of having Redux to build your app, and you also want to have, for some like advanced components, you want to have complete control, like for example an endless scrolling list. This is a super cool way of doing it. At least it works for us.
Have you looked into React Fire? Maybe also comment on that. Also maybe people don't know.
We haven't.
Okay. Yeah.
So maybe there are better ways of solving this. I can kind of hear from what?
It's like the next version of React.
Yeah. We haven't looked into it.
Okay.
What we did actually do was build. We don't just have a bunch of like old school like JavaScript app things calling like functions in and out and everything. We sort of organize it in something that looks like React, and we even describe the components inside the canvas with something that looks like JSX, and it feels a lot like React, but it's really not. It's just something that pretends to be React. So
you shouldn't necessarily have to, or just if you try it, because the React Fiverr is not ready yet. There's even a website called is Fiverr ready yet.com, and this basically says big no.
But it's a lot of the things we've done isn't really ready. I wouldn't recommend WebGL for production necessarily. We have seen like odd browser bugs and stuff that's difficult because it works seen from a coding perspective. You don't get any errors and everything works, but it still renders completely wrong on the device. And this is stuff that you will never know, right? You can't track it. Did this render okay? You just have to wait for customers to complain, basically. But we believe that we have like enough test devices and enough testers and enough users that we're kind of confident that we've sort of made it, but it took a long while and it was hard, and it's fragile code, right? It's difficult to change anything in the WebGL code because you never know if you are introducing one of these bugs, and then you need all the testing. So also for an example where I do the thing with the canvas, but I guess you can kind of imagine that you can draw on a canvas. I didn't to show that. It's also a little boring looking in the terminal. What we have not done is to get rid of the last part, this synchronization. Ideally, especially since the dispatch in the reader app is actually, it's pretty heavy. It takes, even on a laptop like mine, it takes up several milliseconds, and that's time that we can't use for drawing, and we do it every frame. And maybe we don't need to do it every frame. Maybe we only need to do it like if there's time for it. And it turns out in modern browsers, there actually is a callback for exactly that. It's called a window request idle callback, which is sort of parallel to request animation frame. It's a callback that when there's time left over in a frame, you get this callback, and you can kind of say, it tells you how much time is there left, and you can kind of ask, so if there's more than 5 milliseconds left, I want to do my dispatch, and if there's not, I'll wait. And then you can set a timeout so you won't wait more than, say, 500 milliseconds. If it's done like that, then you've basically completely detached React, and it's sort of a slave. The React and Redux loop is a slave to this high-performant core. Which is really nice, but at the moment it's only supported in Chrome and Opera. That basically means Blink, I think. And maybe Firefox, I'm not entirely sure. They rumored it would be in Firefox 52, but I can't seem to find it, and I'm at Firefox 53, I think. So, other stuff that we've seen that impact animations. That's image decoding. Like when you download an image, that's asynchronously done. That's just a web request. But when you receive the image and you need to show it, then it has to be decoded, and that happens on the UI thread. And if any of you do like app development in an app, like native apps, you would always put that on a background thread, but you can't in a browser. You can in very modern browsers. I'll get back to that. But that's actually, so when we can't load all the pages in a PDF, we can't load all the images up front. So we kind of have to do it like while the user is paging in the magazine, and sometimes we have to do this image decoding while he's turning a page, and then that's dropped frames. And there's garbage collection. This was going into this project. This was what we were the most scared of, because like when we learned about like fluid animations in JavaScript, this is like what all the talks talked about. This garbage collection. Don't release any memory and keep strong references to everything, because you want to reuse elements and you want to do all the stuff, and that is complete nonsense in today's web world. Garbage collection doesn't really take time in at least in a browser world. Maybe on a on a server under a heavy load, garbage collection does take time, but it's a generational the garbage collection algorithm, which means that it basically, whenever it creates object, it just creates them in a small bucket, and whenever that bucket is full, it loops over it and figures out, are there any references to it? And at least in our app, this happens super fast, and objects that are referenced to it, it moves to a bigger bucket, and then it keeps it there, and it periodically cleans up the bigger bucket also. And it can do like also smaller passes, do like just look at a little bit of the bucket, and when it seems to have time for it, and in practice, this takes like a sub-millisecond times doing a garbage collection pass, and it does it all the time, and it's perfectly fine. So this this is sort of a myth busted, at least from our reader's perspective. In quite the contrary, when we were holding strong references to a lot of stuff, because we have a lot of big images, we have a lot of like textures in WebGL, and we have a lot of fonts loaded, we were actually seeing crashes on a lot of mobile devices because we were just using too much memory. So instead, release memory whenever you're done with it and just have it garbage collected. That's much better. Heavy style updates. If you change a style sheet, load a style sheet. For us, we load all the fonts for a page. We load that when you turn to the page. That also happens in a UI thread, and it takes some time. In some browsers, there's a native font loading API that we are trying to take advantage of, but that's also a very experimental feature. So if you're not seeing these problems, you probably shouldn't be messing with that. Console log is a huge strain on performance, so don't do that in production apps. And other blocking actions are like decoding large JSON blobs and stuff like that. Sometimes it's unavailable, but if you can like not decode JSON while you're animating, then that's good. Yeah, this is the image decoding of the main thread that I was talking about. You can actually, there is this thing called create image bitmap, which is supported in at least Firefox, Safari, Opera, and I think desktop Safari. I'm not entirely sure. Not in Internet Explorer or Edge, unfortunately, but Microsoft is considering it for Edge. But easy to feature detect for, and that can be used in a web worker. So you can do like with code like this. It's a few more lines than just doing like new image and image source this, but it's not that much more, and sort of amounts to the same thing. You get in this callback, you get a bitmap. It's not an image, it's a bitmap object, but it can be drawn on a canvas, and that's pretty fast. And then you have this canvas with it drawn on, and you could insert that into the DOM instead of your image. Or in our case, what we wanted was to draw it on a canvas anyway, so we're happy there. But that's really exciting, because especially it's not supported on very many mobile phones, only some Android phones with modern releases of Chrome. But that will be like that will be awesome for all web pages when lazy loaders for normal web pages start to support this, and it will work on mobile phones, because that's what's making scrolling on a mobile phone jarring and stuff like that when images are being decoded on the UI thread. And that's what I had to say. I sort of made it inside my time frame.